Sine and cosine of complementary angles. The acute angles of right triangles are complementary. This plays out in some interesting ways. So we know we have alpha and beta here, and we have a right angle. Therefore, alpha plus beta equals 90 degrees. So if we solve this for beta, we get angle beta here equals 90 minus alpha, because we just move this alpha to the other side. And down here we have alpha equals 90 degrees minus beta. But visually, look what we can confirm. Sine of alpha, so sine of this angle, would be A over C. The cosine of beta would be A over C. So we have the sine of alpha equals the cosine of beta. So that's how this relationship between these complementary angles is interesting. Here are some true or false questions. True or false, are these triangles similar? Well, we're given the side lengths, so let's use the SSS, the side similarity theorem. We have 3 to 4 to 5 equal to 6 to 8 to 10. So if this is true, if these sides are all in proportion, then the triangles are similar. And we can see that that is true. 3 times 2 gives you 6, 4 times 2 gives you 8, 5 times 2 gives you 10. So yes, this is true. These triangles are similar. Next, sine A equals cosine B. So A is here, B is here. So yes, that is true, because we just learned that the two interior angles that are acute in a right triangle are going to have this relationship. Do those both equal 0.8? Well, let's check. Sine A equals 8 over 10, which is 0.8. So yes, this is true. Cosine B would be 8 over 10 as well. So yes. Moving on, 5 times sine B equals 4. Well, let's figure out what sine B is. Sine B equals 6 over 10. And so if we multiply this over to the other side, we get 10 sine B equals 6. We can divide both sides by 2, and we get 5 sine B equals 3. Oh, that says 4. So this one's false. This should be 3. All right, I'm going to delete this. Let's move on. Cosine A equals sine times 90 degrees minus A. Sine of 90 degrees minus A. Yes, this is true because we learned this in the last slide. Cosine of A would be 6 over 10, which would be the sine of the complementary angle to A, which in this case is B. So sine of 90 degrees minus A, 90 degrees minus A equals angle B, and as determined up here, we know that this relationship is true. All right, moving on. 5 times cosine P, so cosine P equals adjacent over hypotenuse, which is 3 over 5. So multiply both sides by 5, we get 5 cosine P equals 3. So this equals 3. 10 sine Q. All right, so 10 sine Q. Well, what is sine Q? Sine Q equals 3 over 5. So that is 5 times sine theta, or Q, equals 3. And we want 10 times sine Q. So we'll multiply both sides by 2. So 10 sine Q equals 6. So this portion here is 6. This portion here was 3. So this should be equal to 9, not 6. So this is false. And finally, we have cosine Q. Here, cosine would be 4 over 5 equals sine of 90 degrees minus Q. And that is true for the same reason that this one was true. This is the relationship. So 90 degrees minus Q will give you angle P, because they are complementary angles, and this is true. There we go.